Welcome, dear guests, distinguished speakers, honorable VIP. Thank you for coming to the Graveyard Shift. I hope everybody's still excited for the last session of the day. I heard in Dubai, it's the time when everybody just start functioning. So let's get onto it. Today, we'll be talking about the proposed of emission factor and GHG emission reduction method on peatland ecosystem based on GWL in Tier 3 measurement. So in accordance with Indonesia's commitment to the Paris Agreement, GOI has prepared a long-term strategy for low carbon and climate resilience, in short, LTSLCCR 2050. This document explains that Indonesia will increase its ambition to reduce GHG emissions with peak national net GHG emissions in all sectors achieved in 2030. In that context, the Directorate of Peat Ecosystem Damage Control developed a study of calculation methodology for GHG emissions and absorption, which requires an integrated information system from other sectors. So today, we will explore the methodology for measuring the reduction of carbon emissions through groundwater level monitoring and calculating GHG emissions in peatlands. Okay, since this topic is all about the scientific work and research, I have no one better to host the session. And he's also our graveyard shift keeper. Please welcome Dr. Suryo Adiwibowo.
Good night, dear. I think it is already night. I said good night because all of us aware this is, we have to manage the time for our presentation and discussion. First, allow me to address our honorary guest, the Vice Minister of Environment and Forestry, Mr. Aludohong, and I give the first session, the keynote from our Vice Minister. Please, Dr. Aludohong.
Thank you, Pak Bowo. Distinguished speakers, participants, ladies and gentlemen, a very good evening to all of us. It is my great honor to give an opening remark, actually, not a really keynote speech, but opening remark of this session entitled Proposed of Emission Factors and GHG Emission Reduction Methods on peatland ecosystem based on groundwater level in Tier 3 measurement. And I'm delighted also to see so many friends here, so many experts. And I particularly mention here, we have Adrian Elvian, professor. He is now the one of the IPCC member representing Indonesian government into the IPCC panels. We have also here Professor Supiandi Sabiham. He is considered as the guru of peatland in Indonesia. And we have also Professor Osaki from Hokkaido University, also Japan Peatland Association, I can call it like that. He's also considered as a guru of tropical peatland because he does a lot of research in Indonesia and other tropical countries. And who else? Yeah. Oh, Pak Sopian Kurniantun. He's also one of the tropical peatland experts in Indonesia and with well-known publication and so on. And many others here. I think all in this room are expert on tropical peatland. Ladies and gentlemen, we know that tropical peatland in particular is a very important ecosystem which provides ecological economic, social, as well as climate change services to this global world. Even though Peatland just occupy like 3 to 4%, is it right, Faisal Paris? Yeah, of this global landmass, but actually it's contained between nearly 30 to 35 of the global carbon in the terrestrial. You can imagine how big it's this peatland. And tropical peatland in particular, actually, located in more than 60 countries, but there are more or less 3 countries that hold the largest tropical peatland in the world. One is Indonesia, second is Democratic Republic of Congo, and together with Republic of Congo. So these 3 countries actually hold the largest tropical peatland in the world. Indonesia itself, we have around 13.4 million hectares of tropical peatland. That's just peat, right? But if we talk about the hydrological unit of peatland, we have around 24 million hectares. And this is located in Sumatra Island, Kalimantan Island, Papua, and small part in Sulawesi. And DRC and Congo Republic contain around 13 million 13 million hectares. Based on some research in Indonesian, like 13.4 million hectares contain between 48 up to 55 billion ton of carbon. You can imagine the recent report published by UNEP. Actually, the gap emission up to 2030, if we want to achieve 2 degrees up to toward 1.5 degrees, the emission gap right now is about 43 gigaton carbon, or 43 billion ton of carbon. So Indonesian peatland even have more than that kind of gap, right? However, to be honest, while recognize the importance of tropical peatland in terms of social, economic, ecological, including climate change, the big challenge actually related with management of this peatland. So challenge in terms of conversion of peatland, peat swamp forest to other land uses, like used to be for logging activities, for large scale of agriculture, and including, industrial forest plantation, association with drainage activities. So even based on the study done by International Union for Conservation of Nature, actually globally emission from drainage peatland is about 1.9 gigaton of carbon CO2 emission annually. You can imagine huge of it. So that's one of particular. But learning from past experiences in Indonesian peatland practices, we build, something that new. Start from a couple of years ago. We understood and we realized that managing tropical peatland with drainage base was not really proper intervention. So that's why we changed it. So Indonesian government, as well as in collaboration with private sector, with the scientific communities, and including NGOs and so on, we try to find a solution how we can address this peatland degradation from drainage, from unsustainable conversion, from fires and so on. And we find some solution and recommendation and practices. We call it in particular peatland restoration, right? And Indonesia started to, to initiate this kind of peatland restoration activities. I myself, with Faisal Paris here, I know he's my long friends, We started it in 2002 even, yeah, to introduce, we call it peatland, hydrological peatland restoration in Indonesia, Kalimantan and Sumatra, Kalimantan particularly in ex-mega rice project, and Sumatra, even in Kuala Selangor, yeah, in Malaysia. And we start to introduce, we call that rewetting of drain peat program. So we introduce like building rewetting infrastructure like canal blockings, canal backfilling, canal weirs, whatever we call it. And we also introduced, like in Indonesia, we apart from the hydrological rewetting infrastructure, we use a 3R approach, yeah. First is the rewetting program, or first R is rewetting of drain pit through building all this kind of rewetting infrastructure. Second is revegetation, try to get back all this kind of pit vegetation after the drains, after the hydrological restoration completed. And the third R is revitalization of local livelihood. So in this revitalization of local livelihood, we use also 3 approaches in particular. First is we call it water-based livelihood. So we can doing a livelihood in peatland based on drain approach. So we use water-based approach because peat, in particular, tropical peatland actually contain 90% water or hydrological. The other 2 elements, peat substrate and vegetation, is small part of it. So the best thing is to use, we call that water-based approach. And second is like we also promote environmental services approach for livelihood. So there are so many services in the peatland, even hydro, biodiversity, water, fresh water in particular, and ecotourism and so on. That we promote that, including recent discourse about carbon and so on. So that's kind of the proper approach to use, to develop a livelihood in peatland. And Indonesia is the spearhead, to implement this. Our achievement, to be honest, we implement those after some years of lesson learned that we are doing on the ground, how to do this peatland restoration is we try to scale it up, to expand it, not only within the community lands, but also into the private companies or concession. So that's why we introduce all this kind of approach within the industrial timber plantation, palm oil, and other local communities peatland management. So based on our data, especially, for example, Ministry of Environment and Forestry facilitate the companies like, industrial timber plantation and palm oil to implement this rewetting infrastructure within their concession, to build canal blocking, canal backfilling, whatever, in order to maintain this water level during the drought period. So based on the data, up to this year, we already implement this kind of rewetting intervention within concession areas around 3.78 million hectares. That only in concession areas, industrial timber plantation, as well as palm oil. And actually, the BRGM, if you know the BRGM, Badan Restorasi Gambut and Mangrove. So Mangrove and Peatland Restoration Agency also implement this kind of peatland restoration or rewetting infrastructure construction within the non-concession areas. So they are already between 2016 and up to 2020, they already done in 834,000 hectares. Yeah, and between 2021 up to 2022, about 540,000 hectares. So you can imagine how huge is that if we combine within community lands as well as the corporation areas. And total rewetting infrastructure that already built within concession areas up to now is about 28,207 canal blocking and canal backfillings units, yeah? That's only in concession areas in Indonesia. Meanwhile, in the community areas, BRGM already constructed with communities about 7,745 units of canal blocking and 184 units of canal backfilling and 14,087 units of deep well. You can imagine that kind of huge rewetting infrastructure that we build in order to address our peatland degradation through a rewetting program in Indonesia. Apart from building this kind of rewetting infrastructure, vegetation, and local livelihood, we also established monitoring system, particularly in KLHK, yeah, Ministry of Environment and Forestry, and Pak Askari within the Directorate General of Peatland Management, yeah, always facilitate companies to establish groundwater table monitoring devices on the ground. So now, even we already install, yeah, together with the companies, 10,771 unit of groundwater level monitoring system. Huge, right? This is capital, scientific capital, I can call it. And this spread out within 232 hydrological units in Indonesia. This is a huge monitoring system, and also, of course, costly because we combine between manual groundwater level and automatic groundwater level devices, yeah, and combine it with satellite monitoring system. And even we build a web-based system to collect all this data, to present all this data within the Ministry of Environment and Forestry. We call it CMATAC -0.4 meters. Because there is a regulation in Indonesia, all companies who has, you know, like concession in the peatland, they have to manage water table a maximum 40 centimeter below the pit surface. If beyond that, they're gonna get fines. They're gonna go warning from the government. So the threshold is you have to maintain water table maximum, I can say maximum, yeah? Maximum, yeah? Not minimum, yeah? Maximum 40 centimeter below the pit surface, yeah? If you beyond that, you're gonna get warning and sometime, you know, penalty. This is based on our regulation. And this threshold, especially during the drought season, yeah, or particularly during El Nino season. During the wet season, actually we disregard it sometimes because some 40% of peatland in Indonesia during the wet season is just flat areas, yeah. This is the big challenge, right? we have all this kind of monitoring system. We have collected, all this data, including within the companies and so on. Meanwhile, this is the very important, the last part of my opening remark. That's why we have this kind of session today. We have, to be honest, Professor LP and Adrian, yeah? We have 2013 supplement to the 2006 IPCC guideline for national GHG inventories wetlands, right? And this IPCC guideline actually provide methods for estimating anthropogenic emission and removals of GHGs from lands with wet and drained soil and constructed wetlands for wastewater treatment. But this, to be honest, I can say it's old-fashioned already, yeah? You can imagine it's published in 2013, yeah? And most of the data put in this emission factor in this IPCC guideline based on very limited research. And many of this publication research is on temperate and boreal peatland. So it's not really suitable for tropical peatland. Meanwhile, in many years, recently years, so many research already done in Indonesia, in Malaysia. Is that right, Pak Bashal? In other tropical countries. How we can measure all this kind of emission from land uses within tropical peatland, either for agriculture or for, other crops, including from the hydrological management within tropical peatland. So we need to get this recent scientific data. And I believe all this, I mentioned some of the gentlemen area. Sorry, I don't mention about the lady researchers, but I do believe many ladies researchers here. They want, all of them actually considered as a guru of tropical peatland. And they done so many research already on it. So we have to update, emission factor that's put into this 2013 supplement to the 2006 of IPCC guideline for national GHG inventories for wetland. So I look forward to see all this kind of new findings, new research results by all these gentlemen or maybe ladies or whatever later on. And we can channel all this information to Professor Aldian. To be honest, Prof, yeah? Because he's representing Indonesia in the IPCC panel. And 2 days ago, I also discussed with Vice Minister from Japan, Osaki Sensei. I just met him 2 days ago. And also as a convinced, IPCC member from Japan to support this, in order to get a precise and rigorous emission factors from tropical peatland management combined with boreal and temperate peatland. So we can come up with new emission factor. So because the IPCC is a government body, right? So I believe if many countries with tropical peatland work together and convince the IPCC panel, I do believe we're going to succeed to get something new that really precisely rigorous and so on. So I'm talk too much, so I end this speak or remark, Pak Bowo, and thank you very much for all your kind attention. Good evening. Yeah.
Oh, what a big remarks for you, sir. This lecture. Because rich with data, rich with number. And my perception, the committee invited me to become a moderator. This is not about the number of what is the appropriate water level on the peat ecosystem. But this is also from the social sciences, this is struggle for knowledge. And this struggle are between the global and the local. And then I agree to you, sir. This is the time for us to convince the global community, particularly with regard to the UNFCCC, that this kind of number, this kind of scientific finding has already in the place. We have empirical data. So with regard to this, I invite 5 speakers. The first I invite to the stage Dr. Sofyan Kurnianto from the Research and Development of the PT Rio Andalan Pulp and Paper, all in short, the April Group, please. Pak Sofyan. And the second, Dr. Bandung Sahari from the Astra Agro Lestari. The third, the 2 of them are the private company who engage daily with the problem of the peatland ecosystem. But then this session also invite 3 prominent speakers from the academician, Professor Mitsuru Osaki from the Hokkaido University, which is already engaged long with the issue of the peatland ecosystem. Professor Supiandi Sabiham from the University, IPB University, he also a soil scientist. And the last but not least, Professor Edwin Adrian, that also become the member of the IPCC with regard to the peatland ecosystem. So, this is the the last session. I will invite you all to address, perhaps you agree, 8 minutes. How about that? Because usually Indonesian speaker, 8 minutes become 15 minutes. So, no problem, sir. Because all of them didn't know exactly about the peat ecosystem, yeah? And about the progress, how massive the government and also the private company to launch, to control our peatland ecosystem. So I will invite first, according to this agenda, Dr. Sofyan Kurnianto, would you please short to address the issues, please.
Good evening, ladies and gentlemen. This is kind of like deeply grateful for me to present our recent nature publications. My sincere thanks to Ministry of Environment and Forestry, Government of Indonesia for this opportunity. And my special thanks to dedicated teams in Riau, Sumatra, Indonesia, and all co-authors for various institutions and universities. Next, please. So I'm Sofyan Kurnianto. In the upcoming slides, we will delve into how we improve the methodology and use one of the most advanced technology to monitor greenhouse gas emissions from various land cover types in tropical peatlands to estimate the Tier 3 emissions factors. We gonna present why and how we do the research, and then what are the key results in which the net CO2 emissions in acacia plantations is higher compared to those in intact peat swamp forest, but lower compared to IPCC emissions factors. We also highlighting the importance of tropical peat swamp forest for avoiding the increased emissions. So it's just kind of like echoing what Vice Minister said, that tropical peatland is very important ecosystems by storing a huge amount of carbon. However, because of the land use change driven by the economic growth and populations, so the stored carbon released back to atmosphere. However, due to kind of like the lack of measurements in the tropical regions, especially in the tropical peatlands, we can see here the map of a decovariance tower to measure greenhouse gas tower. Most of the measurements occurred in the Europe and the Northern America, but very few measurements in the tropical regions, particularly in the tropical peatlands. This kind of like lack of measurements resulted the variability, big variability and uncertainty in the estimates of greenhouse gas emissions. So to get this knowledge, we would like to kind of like emphasize what are the emissions factor for the tropical peatlands, and then we would like to know mental variables with this kind of like gaseous emissions. We use the methodology called a decovariance in this research. This is kind of like one of the widely accepted measurements, one of the most advanced technology to measure the gaseous exchange between the ecosystems and the atmosphere. This is practically kind of like we measure very high resolutions of CO2 concentrations, methane, and the wind speed of the vertical wind speed. So by having this kind of like measurements, we will have 30 minutes data continuously. So the temporal variability day by day, season by season, and interannual variability of GHG emissions can be predicted. And but in addition, this kind of like methodology is measured at the ecosystem level, meaning that every 30 minutes of the data, it can cover at least 200 hectares. So the spatial variability within the ecosystem can be measured by this technology. From the 2016 until 2020, we measured the GHG emissions from 3 different land cover types in Kampar Peninsula of Riau. So we have intact peat swamp forest, degraded forest, and then the last but not least is the acacia plantations for this kind of like 3 different land cover types. Here one of the main results of these publications. This is kind of like the temporal variability of net CO2 emissions along the plantations rotations. We can see here that the net CO2 emissions is varied by plantation age. It reached the highest at the first year after the planting and reached the minimum after 3 years after planting. And we conservatively assume that all harvested wood will be released back to atmosphere as carbon dioxide. So briefly, the total emissions from the net CO2 exchange from the plantation cycle plus harvested wood make the CO2 emissions as the carbon source to atmosphere for about 30 tons CO2 equivalent per hectare per year. And this is kind of like lower compared to Tier 1 IPCC emission factors. By comparing the total GHG balance among the land cover types, we can estimate the net impact of land use change on the GHG emissions. For example, for the total GHG balance, we included all 3 main gases, carbon dioxide, methane, and nitrous oxide, plus the lateral export from the aquatic systems, and the biomass loss due to the land use conversions. So we compare the intact peat swamp forest and the degraded sites with the acacia plantations. It shows that the total GHG balance in the intact sites is lower compared to those in the degraded sites and the acacia plantations, implying that if there is kind of like conversions from the intact peat swamp forest to acacia plantations, it will result in the net increase of GHG emissions. This net increase is still lower compared to the conversions of intact peat swamp forest to degraded sites. If we are seeing at a different angle, so for protecting the intact peat swamp forest will result in the avoided emissions of 25 tons CO2 equivalent per hectare per year. And this is kind of like the big number of reductions emissions. So we also calculated the avoided emissions using to use the biomass combustions to replace coal from from these measurements. If we are putting all together the number from the eddy covariance tower within the tropical ecosystems, we can find that at every different land cover, at every different groundwater level, the net CO2 emissions estimated by the eddy covariance towers is consistently and significantly lower compared to the CO2 emissions from the subsidence and soil chamber. And this consistency is also occurred in the northern peatland. So by having kind of like these equations, if we know the annual average of groundwater level, we can predict the net CO2 emissions at the kind of like from different water table. So we can use these equations to estimate the net CO2 emissions from our sites. So I'm closing this kind of like my talk into that we are not done yet. So even though we already estimate the tier 3 emissions factors, but we would like to know more what's happening in the lower ground. So we would like to know the process-based understanding by measuring the CO2 emissions from stems, from aquatic ecosystems, and what are happening in the smaller scale. I think that's all my talk, so we can have a discussions if you have any further questions.
Thank you, Pak Sofyan. Rich with data, but perhaps not all of you can digest this number, but don't worry about that. Second, Dr. Bandung Sari, would you please address?
Yes. Very good evenings, everybody. Thank you, Pak Bawo. So since you limit our time less than 8 minutes, and then I'll try my best to quick as possible. So thank you very much for the opportunity given to us. I see this as an opportunity to share our work in the past and also to share our thought about the greenhouse gas emissions on peatland. So in this opportunity, I would like to highlight our presentation here is the GHG emission study based on groundwater level on oil palm plantations on peat in Indonesia. Okay, so this is the outline of my presentations today. Is the first is the peat and climate change, and the second is the oil palm industry in Indonesia, and the third one is about the GHG emissions in oil palm industry. And the fourth one is about the SCV conservations in oil palm plantation and carbon market, and also the conclusion. Okay, I think everybody is aware about this. This is from IPCC that provides many technology, the carbon dioxide removals. And in oil palm plantations, it can be conducted to achieve the net zero by conserving the SCV area and also peat restorations and also soil carbon. And this is the flash of Indonesian commitment about the climate mitigation. And this is the profile of palm oil industry in Indonesia that you can see here that the production increased by year to year. And also, it is expected by the end of this December, so then the productions will reach around 53 million palm oil. And what about the emissions in oil palm plantations? I think there are many studies that have been done related to the emissions from oil palm plantations, but in this opportunity, I would like to highlight the study conducted by Tiong and Che in Sumatra. So as you can see here, that there are three scenarios. The first scenario without peatland, and the second one is with peatland, and the third one is with peatland and also with methane capture. So as you can see here, without peatlands actually and with help of methane capture, so then emission in oil palm plantation is approaching zero. And it is also need to be considered about the sequestrations of oil palm itself. And also there is SCV area. But for the second scenarios where the plantation is peatland, so you can see here that the contribution of peatland will contribute to a significant level of CO2 emission. And what should we do to reduce the emissions from peatland? The first is peatland management. So the implementations of best water management in all palm plantations, and through maintain water level at least 0.4 meter below ground. And we need to study a lot of things related to how to manage the oil palm plantation on peat. And the key factor as analysis should be studied further, including the precipitations, peat moistures, elevations, water behavior, peat maturity, and etc. So actually, Professor Supiandi Sapihan intensively helping us in developing these practices on the ground. And as you can see here, there is the water gate overflow, and this is the technology that we applied on the ground. So what the data says? This is the spots of research that has been conducted in our plantations, and to evaluate the relationship between the rainfalls and also water content and also groundwater level. As you can see here, that there is a dynamic between the groundwater level and also the precipitations. And there is two different type of season here, the wet seasons and also dry seasons. And as you can see here, that precipitation, rainfall, really affecting the groundwater level in our plantations. And actually, there are some of research to relate between the groundwater level and CO2 emissions, but the data is still very limited, and we need to have like more information, more places to analyze the effects of the groundwater level to CO2 emissions. But it is important also to note that the CO2 emissions in peatland, where the oil palm plantation cultivated, it is not only affected with the groundwater level. So many factors affecting the level of CO2 emission. Pak Supiandi will explain that later in very detail, ya Pak. And this is about the potential of the SCV area for the carbon removal. And for the key points to achieve net zero oil palm in 2060, the first is due to global warming concern, the palm oil industry need to reduce its carbon footprint to support Paris Agreement and net follow target in 2030. And the second one, that the greenhouse gas emission study has been made to study the potential to reduce the greenhouse gas emissions. And as I have explained that the emissions from the peatland has contributed significantly in CO2 emission in palm oil industry. It is very important to note that there are 1.5 million oil palm plantations on peat. And so there is an opportunity for carbon market from ACV area in oil palm concessions. It needs technical agreement and upper limit for business entity or persetujuan teknik to conduct the carbon trading from oil palm plantation. Thank you very much. for the opportunity given to me. Terima kasih Pak Bowo.
Thank you, Pak Bandung. And now we invite three prominent professors that dealing many years ago to research about the characteristics and behavior of the peatland ecosystem. So I invite first to present the ideas was the Professor Mitsuru Osaki from Hokkaido University. Please, sir.
Could you give first slide? Yes. So just focusing on the tier 3, how to establish the tier 3 in the tropical peatland. So what is the limiting factors in the peatland? So you know the 3 is a key, the element in the peatland. So water is enough, and the nutrient normally very poor, and oxygen is also very low because of the oxygen solubility into the water is very, very low. This is a coefficient, a physical coefficient. So why in these conditions, the oxygen is come to the limit. If the low oxygen, what happens the biochemically? So the redox potential is come to the low. So we difficult to estimate the redox potential in the ground, also the satellite. Then so we try to evaluate how to estimate the redox potentials. So this is related to oxygen. So why in the peatland we monitoring the groundwater tables. Groundwater table decreasing, oxygen coming into, and so the redox potential is come to the high. So this is our principle to establish the tier 3 model. And so this is just the rough draft. And so time is limiting, so I not explain. This is a native forestry, and so the high waters feel the oxygen supply and feel the composition. But if reduce the water tables, the oxygen come into and decompose to accelerate by microorganisms. Also, if apply the chemical, so nitrogen N2O emission is increasing, and the methane also very increasing because the bottom, the water levels, so the bacteria activity increasing, then so use the oxygen, then redox potential come into the -3 millivolt, then so oxygenase metagenesis, the accelerate, then so the methane is emit. Oh. So what is the natural conditions? So the oxygen is limiting, but in the natural condition, the plant to make an aerial root, or we call the mound root, then take oxygen, and growth is very sustained. And if the reducing the water table, apply the chemicals, so this is very serious, the condition. But instead of the decreasing water tables, so we developing new technology we call aerohydroculture. And so only put something, the organic matters, charcoals or something, the microorganisms put together and only put on the surface, and aerial root is induced and growth is stimulated. So we establishing the flux towers, and so why we establish the flux towers? Because Copenhagen Accord at COP25 recommended to establish the RED plus the mechanisms, and also to evaluate the RED plus mechanisms. So this Copenhagen Accord recommended to MRV systems. So MRV is in this accord talking about use the satellite data and ground truth data to bind together and make something the model. So this is the actually what is so many people are talking about MRV, but this Copenhagen Accord MRV is more specific. So why are we developing the ground truth monitoring systems? So this is the monitoring microclimate and ground surface moistures and groundwater tables, and also we monitoring the land surface, the subsidence. So then, so what is a satellite and the flux? And we also established flux towers, and so applying several satellite data and make remote sensing and the ground truth bind together, and we call the integrated MRV systems. So we now propose three types of the tier 3 evaluation of the CO2 emission. One is NEE. NEE is net ecosystem exchange, and the groundwater table, the functions. So already explained, I forgot the name. Yes, the same technology. And so another is evaluate the ground surface levels, and also which must make a function with the groundwater levels. So two is different methodology, and we make the two and the piling or comparing each of them. So we make a more standard the tier 3 models. And so this is just already explained, the groundwater level is related to NEE. NEE plus means emission, and we use the regression coefficient to calculation of the CO2 emission. And so this is one kind of the models. So we found ground surface moistures and groundwater levels have linear relations, and we use this coefficient. So some other satellite data release the soil moistures, but difficult to evaluate directly the groundwater table by satellite. But using the coefficient, we evaluate on the water tables, and so here is the water tables, and so carbon groundwater table, the coefficient put into, then so we can calculate CO2 emission. This is one model. And the second one is ground surface level monitoring. So this is the monitoring systems. And so if reduce water tables and laser profiler, the evaluation, how much the sinking or sometimes the increasing. And so we are monitoring. And then we found this kind of the relation. And so water table and ground surface movement, the closely related. And then so we can calculate how much the groundwater decreasing, how much the ground surface decreasing, then so calculate the density of the peat, then so we calculate how much the CO2 emission using this kind of the models. So the peat is the swelling by the water supply and shrink and come to the dry, and also decompose the 3 elements, must separate this 3 elements. So this is the changing according to the according to the water table, but yearly, the decompose and this level is decreasing. This is actually how much the CO2 emit using this kind of the models. Okay. So I propose the two models to how check the variability of the models. So the verification is, the cross-check the two models, the NE and ground surface, and overlay. If the fitted, it's okay, but if something different, so we must check more the detail, what happened in this ecosystem. And maybe so, this is what they say, NE model is only 1 point. Then so we need to extend or to invite some another flux tower data and to mix together and developing a more precise element. And also the GOSAT is a GHG emission satellite. And so this is only estimate not the flux but concentration. But if the high CO2 emission is maybe high, then so we can check the two model by using GOSAT. And some another, the GOSAT is from the space, and another method is same the facility that put on the ground. And so this is following the sunlight. Then so we also evaluate even in the clouded condition. And so this kind of the total systems, we can roughly make the preliminary, the model is now already operated in the Burin the computer systems. And we try to make something network, applying some another the press, the release the data. And then so we already published this kind of concept in this two books. And next month, we will release the third book. And so my presentation, very short, but if you need, maybe you can understand some more details. Thank you very much.
That's the difference between professors and the applicable private company in a very vulnerable ecosystem. This is the peatland. Then further, I invite Professor Supyandi Sabiham to address for the next 8 minutes. Thank you.
Oke, thank you Pak Suryo. Pak Menteri, Pak Wakil Menteri yang saya hormati, ladies and gentlemen, thank you very much. First of all, I would like to thank Minister of Environment and Forestry to invite me to be here to present my talk tonight. Yeah. Next, I think this is my topic. Maybe very narrow topic, but I hope you can follow this discussion. Next, please. Oh, sorry. Okay. I couldn't see. Okay, thanks. Thank you. Why we done this research? We were triggered by a report, proposed by US EPA and also IPCC. Both of this emission factor is, to me, is too big. Yeah? Especially reported by US EPA, 95 ton per hectare per year. Yeah. So this is my argumentation. That's why we done this research. The main objective of the research is update the emission, of course, yeah. And the second is to analyze the relationship of groundwater level and the emission. And we also would like to analyze absorption of CO2 by crop in situ. Next. Sorry. This is my selected site. Of course, this is following Pak Bandung. We research on the oil palm plantation. This is my research site for 3 years research activities. Yeah. We dance from April 2019 until December 2021. Yeah. Next. Data collection and methodology, we measure several parameters, and almost we dance a measurement at the interval of 30 minutes, yeah? Especially for peat respiration, net CO2 flux, rainfall, and water content. But for groundwater level, every 1 hour. Yeah? Next. This is our instrument put in the plant research sites. We have the covariant tower and automatic chamber and data logger and GWL, groundwater level, and shelter covered by a solar panel. This is age of the palm oil when we done research about 12 to 13 years old. Next. How to measure the root respiration? It is very important. I want to explain. Yeah, we run the automatic chamber at the distance of 1.5, 2.5, and 3.5. This is representing of the peat respiration from root, yeah, respiration and peat decomposition. But for 4.5 meter is representing of peat decomposition. Why? Because according to our research result before, that this canopy cycle is no root system there. So it is 4.5 meter is almost from the peat decomposition. Next, please. So the research result is like this. It's very important. Of course, the peat respiration influenced by groundwater level and rainfall. Yeah? But peat respiration dominated by root respiration. So root respiration increased by lowering the groundwater level and also decreasing the rainfall. Yeah? But it is very important that all root respirations totally absorbed again by crop. Yeah? So the peat emission from the peat, CO2 emission from the peat is only came from peat decomposition, mostly. Yeah? So that's the emission to the atmosphere we call is emission factor. Yeah? So the emission factor is about the 15 to 18 ton per hectare CO2, depending on the condition, yeah? Rainfall and also the groundwater level. Next, please. Our funding that's quite correspond with the other result. For example, in Malaysia, about vary from 11 to 36, but 36 is still very young. So I think this is very understand, but almost during the age of oil palm 11 to 12 is almost same with our result. Yeah. So I think we confidence that this is a very good data for propose for the next emission factor. Yeah. Please next. Sorry. How to makes how the deep about the groundwater level for to resolve the good good for absorption and also root respiration. From this methodology, we found that the good result for groundwater level is about 0.6 meter, yeah, for root respiration, and 0.7 about meter for absorption. So we have to propose for good result about the absorption CO2 and also emission, low emission, about the 0.6 meter to 0.7 meter. Yeah. Next. This is my summary. So if we look this one, peat respiration as source of CO2 emission is derived from autotrophic or root respiration and heterotrophic root respiration, or peat decomposition. Both of this respiration is influenced by the groundwater level peat and peat water content. Yeah. So, but from autotrophic respiration, totally absorbed again by crop in situ. Yeah. From heterotrophic respiration, according to the photosynthesis process, yeah, so this is totally absorbed by crop in situ from root respiration. But from heterotrophic respiration, partly absorbed by crop for their growth, yeah, and the remaining CO2 released to the atmosphere. So we call it is the emission factor. How to reduce the heterotrophic respiration? Because autotrophic respiration is almost absorbed by crop. So how to reduce the peat decomposition? We have to manage to maintain the groundwater level at the depth of at least 0.6 meter. Yeah. Next. So this is my closing remark. So peat respiration from root increased with lowering groundwater level and decreasing rainfall. Total CO2 plugs from root respiration is completely absorbed by crop in situ. A part of the absorbed CO2 is supported by heterotrophic respiration or peat decomposition. Emission factor for peatland drainage for oil palm cultivation is proposed to be 15.3 to 19 ton per CO2 per hectare per year, depending on groundwater level and rainfall. It is equal to about 47% of CO2 from peat decomposition. So if we have data from peat decomposition by analysis from the other methodology, we can predict that we don't need to the other instrument. We just analyze the peat decomposition. About 40% of the total peat decomposition will be emitted to the atmosphere. For reducing the so for reducing the plug from peat decomposition and optimizing the CO2 absorption, water management must be carried out carefully for maintaining groundwater level at least at 0.6 meter depth. Yeah. So I think this research was fully supported by BPDPKS or Indonesian Palm Oil Plantation Fund Management Agency. Next, this is my references. Next, I would like to thank to our Director General of Environmental Pollution and Degradation Control (PPKL) and his staff who have fully facilitated me to be here. Thank you very much.
The last but not the least, I invite Professor Edwin Aldrian from the Research and Innovation Agency. Please, Pak.
Thank you very much. Good evening, everyone. Thank you for calling me on this presentation, especially for Vice Minister Aludohong and Pak Suryo Adibubo. So I will have the same title for you. Then for my presentation, I will make the focus of the IPCC work 2006. The presentation explains the matter for IPCC 2006. So the format of this review process is 2006 and then finalized in the 2019 report. So and then it is updated by the more for the 2019. So the method introduced here is method 1, 2, 3, the method tier 1, 2, 3. So there are many methods and then especially the carbon intake in the atmosphere. That is very complex system methodology. So this is the demanding right now for the complexity of the data and the requirement. So the tier 2 and 3 refer to high tier method, generally considered to be more accurate for this. So methodological choice for this method tier 1, 2, and 3, it is for individual source sensing categories. It is important for managing overall inventory of the uncertainty. So, however, this method generally more extensive resource and collection, so it many more feasible and more rigorous for every category and collection. So we must identifying the key categories for this method, and then look at this. The key categories I explained here. The key categories is one of the priorities method within the national inventory system, because the system has a significant influence of country of total inventory for greenhouse gas in terms of absolute level and then the trend of and then the emission and the removal of the greenhouse gases. Okay, so the IPCC update the method for 2006 for greenhouse gas inventory. So by updating this, we introduced 2019 method for this. So right now, I and then the guy from UI, so the 2019 is a refinement of the process. So the guy from UI is I forgot the name. And the methodology must be published in reputable journal article and submitted to IPCC. This is the requirement for the anything for the update IPCC method. So the method should be measurable, reputable, and verifiable for MRV. So this is, for example, the method for the any line type used here. This is a very complex method for the different land type used. So you have this, for example, the method for the water level and so on like this. And then you have, I've been doing this since, because I use the method like this in my old days as the weather modification team. So we use rewetting for the ground level water for the peatland analysis, and then we use this very much for the peatland analysis. So the method is very much useful for us. So we know that there's a target for 1.5 degree. So I have to tell you the story like this. In 2018, the IPCC introduced 2052 will be the surface of the global temperature above 1.5 degree. And then 2019 we renew this, and then we call it it will be reached around 2042, so 10 years ahead. So 2052 becomes 2042. And then in 2021, under the special report on the 1.5 degree, that the world surface the temperature around 2042. By the March 2023 this year, after IPCC released the combination and overall report, and then IPCC renew the report again, then we shall meet this 1.5 degree after year 2030. This is very much anticipated, and then very much by the Paris Agreement, the IPCC role on the global stocktake and the inventory. So under the implementation of the Paris Agreement, IPCC has a special duty to implement global stocktake. The Intergovernmental Panel on Climate Change released on Monday to update this methodology by government estimate their greenhouse gas emission and removal. The role of IPCC in this method, and then bringing sign to the global stocktake and local region methodology from the simple to tier 3 method. So the global stocktake will introduce IPCC as part of the IPCC role for the Paris Agreement. Report has to be delivered 5 years based on satellite measurement. So this is a new method that will be introduced, for example, for the water and ground base in Peatland, as a basis of the other measurement for adaptation mitigation and other financial measurement. The observation period will be repeated for every 5 years since 2023. I think this year will be the first beginning of the global stocktake. The character of global stocktake will announce the whole world as determined by the measure value of the national determined contribution. So the country who does the commitment can be surely determined by the calculation. The calculation determined by the satellite observation. So if you are green, become green. If you are red, become red. If you are pink, become pink. So it will be determined whether a country reaching a 1.5 degree target by the national determined contribution. In country level, the satellite observation will tell you the real color of the observation. Yeah, I think that's all I want to say. I think, I think that is everything I want to say. Thank you very much.
Well, all the honorary speaker already addressed the opinion, the thinking, the research result. And if I would summarize, this is the battle of peatland ecosystem, the battle of knowledge. If you win the battle through the empirical research, then we can convince the IPCC that the IPCC should perhaps correct their value, their estimation, but they need a scientific reputation journal to convince them. And I'm not what you call it confused, because you already done that. The time is now to write in the reputation academic journal. and we flooded the UNFCCC with the scientific finding. But the time is almost 1 hour for a presentation. So I will allow perhaps only 15 minutes. You already sit about 1 hour to hear all the presentation, and it will be valuable if you could give some correction, some what you call argumentation with this kind of findings. This is rich with data, rich with perhaps for you boring, but I will remind you that knowledge is power. Knowledge is, if we can have many knowledge on that, then we are, Indonesia and the other country, have power to convince the UNFCCC. Any can would comment on that? Yes, please, Pak.
Okay, I won't talk for 10 minutes. Yeah. Okay, Faisal Parish, Global Environment Center, Malaysia. Yes, I think there's been a lot of work which has been done in Indonesia and Malaysia, other countries, since the IPCC report. Even the IPCC 2013 report, mainly the data was 2010 and before, because that was the rules that had to be, there was a cut-off period. So I think this is going to be one of the issues moving forward. If thing is not already published now, the revision of the IPCC guideline, I mean, it has to be taken already published, and normally there's a threshold date. But I really think it's very important for Indonesia to push forward to IPCC, one, to update the overall guidelines on the updating, but the wetland supplement from 2013 needs to be updated because we have maybe 5 to 10 times more published information compared to them. And definitely some of the emission factors which were in the 2013 supplement and 2006, I was a lead contributing in both of those. The data now available is much, much more, and we have much more robust, as presented some of the presentations, much more robust things. And I think it's very important that in the IPCC, they've just come up with a lump figure for oil palm, so many tons, but nothing about differential figure related to water level. And the work being done by Indonesia in these years to regulate and increase water level, and then the data according to water level is the critical one for management. So I think this is something very important to rapidly move forward. So we hope that Indonesia representative on IPCC, together with those from maybe other ASEAN member states who are familiar with the issue, can bring the issue forward. But also we need to compile the data from Indonesia and Malaysia, the published data, and put forward things. I also believe that there is mechanism under IPCC. They have the emission factor process, which is a little bit more flexible, doesn't wait for the formal review, and we can also put in credible research-backed emission factors into the IPCC emission factor database, which I don't know if it's still maintained in Japan by IGES, but I think those are other mechanisms to put this data forward so that any future studies, NDCs, other things are following the up-to-date information. Thank you very much.
Hello.
Thank you, Faisal. I think what he proposed is quite interesting and powerful. Perhaps you can give comment. 1 minute, 1 minute, 1 minute.
I think for this one, I forgot the name of the expert from IPCC. It's the UI expert is Johnny Jupesta. I think everyone should recognize him. He bringing this method in the IPCC. And then I know that some publications are really high for nature publication, so it is could be recognized as IPCC because this is the only method that they can use if recognized by IPCC. Thank you.
Thank you, Pak. This me? Yeah. Okay. Okay. Thank you, Pak Faisal. I think Pak Wamen said that we are his guru. So Pak Faisal is Mahaguru. Yeah. Do you know Mahaguru? Yeah? Okay, thank you, Pak Faisal. I think it is a pretty good. That's why we also want to push. Yeah, that's emission factor report by IPC, and of which that I myself is also inside of the written the report. So I would like to push that for emission factor, for the next emission factor should be changed. Of course, this is based on report, a journal, very prestigious journal. Yeah? So I think it is okay. But I would like to push Pak Adrian. So this is our data report by Pak Sofian and also our activities. I think confident to be to have changed the emission factor. Yeah. Thank you, Pak Faisal, for your support. Yeah.
So the IPCC, the report is still only the tier 1, and so upgrade to tier 2, tier 3 is very important, but IPCC themselves don't know how to upgrade it. Yeah. And so we must propose this side because of our group also very focused on this kind of how to establish a tier 3, and so, but this is the only small group. But now, so the groundwater tables monitoring the several the location established in Indonesian government, and also some monitoring the flux towers. And so why now we can accelerate to combine or make something alliance? Then so the propose the tier 2, tier 3 level to IPCC. Otherwise, nothing to move.
Thank you, Professor.
Okay, yeah, we are in plantations industry actually for Astra Agro started through Indonesian Palm Oil Associations that we are developing together, ya Pak Supiandi, with Himpunan Gambut Indonesia to develop a series of research regarding to produce the exact down-to-earth number that really representing the emission factors on the grounds. And then I'm in line with you, Pak, and Pak Adrian, and that international publication is very important to really define what the emission factors for the tier 3 in Indonesia. And we are from the private sector to really supporting that idea to get that number. And I'm personally also intensively discussed this with Dr. Johnny Jupasta in Japan, that is also representing Indonesia, right? So yes, we are very committed on that areas, and we are in line with this effort. Okay, thank you.
Thank you. Dr.
It's just kind of like repeating what have been said before, that our data have been published in Nature. I think that's kind of like one of the credible journal. So I hope the data can be used to update the emissions factors. And if the needed more data, the data in the publication is also uploaded in the systems. So everyone can access the data that had been published in the publications.
Thank you, Pak Supa. Here are the situation. I think I recommend to you, Mr. Vice Minister Pak Aludohong, how to orchestrating all the findings. Let's do it together. Make a meeting that the scientists, also the practitioners, the company, working together to publish 20 pages at the maximum. What is for the recommendation to the IPCC, but also it was supported by technical paper, journal as an appendix. So I think this is all the parties working together. We can also convince the IPCC there should be another new emission factor that in the tiers 3. not the first and the second, but the tier 3, based on the field investigation. The field investigation, she cannot be denied if we support with the data. You guys already presented many very rich and convincing and robust data. So I think this is the time I will close the session with homework for all. You publish the scientific paper, you publish the monitoring, and Pak Aludohong as the Vice Minister, combine effort to all of you, make a position paper for Indonesia to the IPCC. Thank you very much to all the participation, particularly our speaker, honorary speaker. Give big applause to them.